Hi, my name is Aruna Ramkrishnan, and I'm the CTO and co-founder of Copernic. We're actually not spun out of MIT, but we're a portfolio company with the engine, which has been built by MIT. Our executive team comprises of myself and Copernic CEO Jacob Gross, and between the two of us, we have a fair bit of industrial experience, specifically in the chemicals and the energy sectors. Now, Copernic is all about catalysts, but the first problem that we're focusing on is ammonia production. The first thing to take away is that all of man-made nitrogen actually starts with ammonia. In fact, of the 180 million tons of ammonia that are produced every year, about 85% of it goes into making fertilizers to grow crops, which we then eat, meaning that about 80% of the nitrogen in your body comes from man-made ammonia. And every chemical that's manufactured by the industry also contains nitrogen atoms that come from ammonia. So it's a super important chemical, but there's a big problem with how ammonia is made today. The main feedstock for ammonia, which is hydrogen, actually is derived from fossil fuels. The ammonia production process also relies on a century-old catalyst, iron oxide, which means that it requires very high temperatures and pressures to drive the reaction. And so this very old process basically results in huge energy consumption and emissions on the order of 1% of the global emissions today. If we're able to make ammonia in a zero-carbon manner, it also unlocks the potential to decarbonize shipping, which is another 3% of global emissions. So there's a huge problem here, but also a huge opportunity to make an impact on climate. Now, Copernic is looking to change how ammonia is made by innovating on the catalyst. And in order to do this, we're employing a hybrid approach by combining models and high-throughput experimentation. On the modeling side, we're using density functional theory, and physics-based models give us deep insight into how catalysts can actually facilitate chemical reactions. And this gives us predictive ability to design better catalysts. We actually have a high-throughput testing lab where we're making catalysts on the order of grams and testing them in massively parallel reactors. This allows us to innovate on the catalysts in a very rapid manner. And in fact, today, we're at a stage where we have developed and we are in the process of patenting a new material of composition for an ammonia catalyst, which performs multiple times better than the current iron oxide catalyst at low temperatures and pressures. Now, why is this approach important, or why is it impactful? If you look at the way catalyst innovation is done today, in the conventional chemical space, it's completely based upon trial and error. So if you look at how Haber and Bosch invented or they discovered the ammonia catalyst 100 years ago, they discovered iron oxide. They had to go through 20,000 experiments just to discover that simple material. And Haber and Bosch wouldn't be surprised by the way the chemical industry operates today, because not much has changed. What we're doing at Copernic is we're changing the order of experimentation and modeling. Modeling is used currently in a very small capacity, mostly to understand why something works. But by switching the order of modeling and experimentation, we're able to use modeling as a screening tool in order to go through really big databases of materials quickly. And what this does is it has two impacts. One is you can innovate upon the catalyst very rapidly, on potentially on the hundreds of times faster than the pace at which it's done in the industry today. And the second impact is that being able to screen through large databases just allows you to cover more phase space and come up with more effective catalysts. And this is what we've seen over the last 2 years of our work at Copernic. The impact of the improved catalyst is primarily to reduce the temperature and pressure. And so for the ammonia synthesis process itself, we can cut down the capex and opex by 30 to 40%, which is really significant for such a large-scale chemical. The unique thing about our catalyst is that it's a thermochemical catalyst. It's not electrochemical. It does not require a new process, which means that it's compatible with existing assets. So you can repurpose billions of dollars of worth of polluting assets and make an immediate impact on the CO2 emissions in the chemical industry today. Moving to the future, we have a number of different other chemicals in the pipeline after we scale up the ammonia catalyst. And all of them, as you can see, currently contribute about 2.5 gigatons of CO2 to the atmosphere. So there's another huge impact that we're looking to make through our Catalyst discovery platform. Now, our partnership ask is mainly that at this stage where we're just past the R&D stage in the laboratory, where we've discovered this new material that gives an incredible performance. We're in the stage of scaling it up. So now we're scaling up the material, and we're also scaling up the process, building out a pilot plant, and demonstrating that it works at scale. So our ask would be that we'd like to partner with the industry in late 2024 or 25 to demonstrate Copernic's catalyst in an actual commercial asset. We're open to partners from all industries across chemicals, energy, agriculture, shipping, and any others. We're not limited in terms of geography because this is a global problem, and ammonia is made everywhere in the world. So open to all partnerships globally. Please feel free to reach out to either myself or Copernic CEO Jacob Gross. I'll be around for some time at the showcase, so would love to meet anyone who's interested in talk. Thank you.